Now let's look at the last example problem. This is called islands. It's from Cathis. So this is a fun problem. This is a problem that once you think through the idea, then the code is a fairly straightforward DFS. But there just a slight. I think it's to me it's interesting there's a slight logic trick that they need to sort of logic step that I need to think through. So the problem is we are given an image where a cell is either land with L or water with W, or it's covered with cloud indicated by C. So cloud means that the square below the cloud could be either land or water. So the question asks us to determine the minimum number of islands that is consistent with the given image. So for example, in this input, the answer is 1. So we have land, water, water, land, and it's cloud, cloud here. So because if there's a land below the cloud, then we will have a LLLL. So there's a 1. There's a 1 position. There's 1 island. So then, just looking at this example, one might think, oh, let's just turn all the cloud into land. So that will be correct for this problem, but it will not be correct for this. So here we have everything is a cloud. So then, if we turn everything into island, into land, then that will give us a 1 island, but the minimum actually is 0. So all of this should be if we treat all of this as water, then it will be consistent with this. So encourage you to pause the video, try to solve this problem. I think the key is to decide how to deal with the cloud. If you see a C, what are you going to do? So if we see an L, we're going to doing a DFS, right? Find out the island. So while we are doing the DFS, if we see a C, then we should turn that into land, because this may connect us to other land cells to create a big island. However, if we are just scanning through and we see a C, we don't want to start an island, because we don't need an island if we don't have to. But once we are having an island, we want it to be as big as possible. So anytime we see a C, it will treat that as land. So I just want to mention, one might think the idea is, suppose there's no land, then we turn all the C into W. So, but that's not totally correct. Suppose I have a column of WWW here, and then I add this. Well, let's just merge the left part and the right part. Merge this first example and second, but I have a WWW separate them. So then I want the C here to become land. I want the C here to become to stay at C. So we cannot determine this globally. It has to be depending on the local situation. So the key idea is we will scan through the cells. We will start a DFS only when we see a land cell. And during the DFS, anytime we see a cloud cell, we treat that as a land cell. So that will work for this problem. So I think that's all the examples. So have fun with the problem set.